In this video, we're going to be talking about solving a 3x3 system of linear equations, and this will be problem type 1. So there'll be another video for problem type 2 that I will link in the description. Okay, so we're going to first number our equations 1 through 3. Okay, and then we're going to choose two of them and try to eliminate a variable. This will be equation 4. So let's choose 1 and 2. 1 and 2. And here's 2. If we add them with this, which is negative y, and this, which is plus z, and this, which is 5. Okay, so we start doing number 3. Okay, and for number 2, I want to eliminate the x, so I can multiply this first one by a negative 3 out front. Positive 3x will cancel. So I'm going to multiply this whole thing by a negative 3. Write that out. 3 times x minus 2y minus 2z equals 8. If I do that, I get negative 3x plus 6y plus 6z equals 8. Okay, so that is the second one being multiplied out. Oh, it shouldn't be 8, it should be 24, excuse me, negative 24. Okay, and that's the second one, and I'll put the third one underneath that so that it will cancel out. Minus y equals 6. Okay, so the x's cancel out, add down, and you get 5y, 2z, and this one will be negative 18. This is 4, and this is 5. What we're going to do is use 4 and 5 to figure out what z and y are. So I can have negative y. This equation 5y plus 2z equals negative 18. Okay, so let's multiply the top one by negative 5 so that it will cancel out these y's. So that will give me actually just 5 because they're already opposite signs. So let's multiply by 5. That will give me negative 5y plus 5z right now. Okay, so on this one they go away. This one becomes 7z, and this one becomes 7. So 1. Now I can take that and I can go over here or up here into either 4 or 5 and get the solution for y. Let's use this one to number 4. That will give me negative y plus 1 in place of z equals 5. Negative y equals 4, so y is equal to y. All I need is x, so I'll choose any one of these equations. I'll just use the first. Okay, so the first one, when I plug in what I already know, is negative x plus y, which is negative 4, plus 3 times z, which is 1, equals negative 3. Okay, so that's negative x. Let's see, minus 4 plus 3 would be minus 1 equals negative 3. Add the 1, and you get negative x equals negative 2, or x is equal to 2. So our ordered triplet 2, negative 4. Oh, let's try that again. 2, negative 4, and 1 for z. X, y, z. Okay, the second problem that we're going to do, which will be the last one, is this one. So we're going to label these three equations, 1, 2, and 3. It looks like maybe the x for equation 1 and 2, all we have to do is make one of them be multiplied by negative 1 and then they're opposites. So 1 and 2, we get 2x plus 2y plus z equals negative 2. And 2x equals negative 5. So I'm going to multiply this, let's multiply the first one by negative 1. Okay, so that would be negative 2x, negative 2y. Again, this is still equation 1. It's just been change sign on either side. So now we can add 2 and 1 together, and we will cancel out our x's. So the x's cancel out. We get negative 3y plus z equals negative 3. Okay. So now I need to do that again. I need to bring x again. So let's just use the second one because that's what we did last time and that works. We could use the first one and the third one as well. Okay, so the second one is y plus 2z equals negative 5. And then we have 4x plus 2y plus z equals 0. I need to make these two terms opposite because I'm trying to get rid of the x just like I did over here. I'm trying to get rid of the x. So to do that, I need to multiply the top one by a negative 2 because that'll turn this term into a 4x, positive 2y, negative 4z, and 10. Y minus 3z equals 10. Okay, so equation 4 and equation 5. Okay, so now I take equation 4 and 5, put them on top of one another and see what I can do with that. So here we go, equals negative 3, and then we have 4y minus 3z equals 10. Positive 3z and that one into negative 3z. So I do that, let's distribute, so I get negative 9y plus 3z equals negative 9, and is 10. Add those up, the z's cancel, and you get 5y equals 1. Divide by 5 on both sides, and you get our first part of our solution, which is y is equal to 1/5. Okay. Now we can take that 1/5 and put them either into 4 or 5. And so I get negative, this is 4, negative 3 times 1/5, plugging it in right here, this equals negative 3. Okay, so that's negative 3/5 plus z is equal to negative 3. Okay, and z is equal to 3/5 minus 3. Oh, you can't see. Now you can. And let's see, just trying to solve this out. Let's have a common denominator of 5. So I could change that into 3 over 5 minus 15 over 5, because 15 over denominator. So z is equal to negative 12 over 5. Okay, I do need to backtrack just a second. This should have been negative over here. Let's see. I added these together. Was negative 9y plus 4y was negative 5, so I was dividing by a negative 5, which means this whole thing is negative. Okay, so which would in turn make this a negative times a negative, which is a positive. Okay, and when I move it over, it will be a negative. Okay, so that's not negative 12 over 5. The negative 3 minus 15 is negative 18 over 5. Okay, so now we've got z is equal to negative 18 over 5, and we've got x. So x can be found by plugging these into any one of these original equations up here. Okay, so I'm going to look at the first, the 2x equals negative 2. So 2x plus 2y, or 2 times negative 1/5, plus is equal to negative 2. So 2x minus 2/5 minus 18/5 equals negative 2. 20 over 5 is equal to negative 2. And of course, 20 over 5 is 4, so it's going to be 2x minus 4. The other side will get 2x equals 2 divided by 2, and you get your solution of x is equal to 1. Okay, so that one was a little tougher because of the fractions and the sign. The triplet is 1, comma, negative 1/5, comma, negative 18 over 5.